the three forces we have. Okay. And the mass of the car is. So we try to solve this problem. Previously, we worked out several problems. All of them are conservative systems. So we are going to use the conservation of mechanical energy. Now, for this problem, is it conservative system or non-conservative system?
Non,
Okay. How do you know that?
because there's friction involved.
You have frictional force, and this frictional force is not perpendicular to the motion. So it must do some work. This is a non-conservative work. So that means WMC has to be non-zero. So this is non-conservative system. Okay? You want to check if there is any non-conservative force doing work. So it's a non-conservative system. We cannot use the mechanical energy conservation. We have to use the total energy conservation. Okay. In the most general form is delta E, the change in the mechanical energy, equals to WNC, the work done by all the non-conservative force. So that's the equation we're going to use to solve this problem. Okay, so that's analysis of the problem. Any question here? So for this unit, you always start with this process to identify one equation you can use for this problem. Okay. Any question here? Now, if you don't have question, let's write down the equation in the detailed form. Delta E is the change in the mechanical energy. So it's the final mechanical energy subtract the initial mechanical energy. So it will be final mechanical energy, which is final K plus final U. Initial mechanical energy, which is initial K plus initial U, okay, equals to WNC. Here, that's the work done by all the non-conservative forces. If you look at this problem, how many non-conservative forces do you have? Okay, we have three forces. How many of them are non-conservative forces?
2,
Which two?
normal and friction.
Okay, so you have the normal force and the frictional force, two non-conservative forces. That means WNC can be put into two terms. The work done by the normal force and the work done by the frictional force. Any question for the origin of each term here? So how can we write down this equation? In the formula sheet, of course, you can only find the general equation like this. Delta E equals to WNC. For any particular problem, you should be write the correct detailed form. For this problem, it looks like this. Okay? Now, what we want to find? The kinetic energy and the bottom. So for our case, it's the final kinetic energy. So that's the quantity we want to find. Okay? So it's okay. It appeared in this equation. So we just need to figure out all other terms and calculate final K. Okay. So this is our initial stage A. This is our final stage B. Okay? So now let's look at before we put the number, the exact expression for each term, let's first identify all the zero terms. Okay? Any zero term here?
Yeah. U final. Yeah.
U final, okay. First K naught is easy because the initial velocity is zero, right? V initial equals to zero, so K initial must be zero. So this goes away. And U final, please note that for the gravitational potential energy, you can always make either U final or U initial zero. Okay. If we choose ground as our 0 point, then final height is 0. So the final gravitational potential energy is zero. Okay, so this is zero. Anything else?
The work done by the normal force?
Wn, the work done by the normal force equals to zero. What is the reason?
Because it's perpendicular to the motion.
Normal force perpendicular to the motion. The motion is like this, and normal force is like this. So we have 3 zero terms. So finally, after simplification, we have k minus u naught equals to wf. So that's the equation we are going to deal with. Note here we have minus, okay, because they have a negative side here. Now, so we just put the definition of these terms. K, that's the quantity we want to calculate. We just leave it there. U naught can be written as mg y naught, okay? And y naught equals to what? What is y naught? 2 meters, okay? Initial height, 2 meters is given. Now, let's look at how can we write down the work from the definition. The work from the definition should be the force, F, which is 5 Newton, is given, okay? Multiplied by distance of the work. What is the distance here? 6 meters. And multiplied by cosine theta F, okay? That's theta F is the angle between the frictional force and the direction of the motion. So what is that angle?
1. Well, it turns into 1.
180. Okay, 180 degrees. Do you have any question? So the angle here is 180 degrees. So cosine theta F equals to cosine 180 equals to what?
1? Or negative 1?
Cosine 180.
Negative 1.
Okay, so this equation actually k minus mg y naught equals to negative f. Okay? In fact, if you are familiar with the frictional force, you can even directly write on this. Frictional force is always opposite to the motion, so the angle is always 180 degrees. The cosine 180 is always negative 1. So the work is always negative ft, the work done by the frictional force. Okay, but you can just do that. Any question here? And now, you just need to put the number k minus 3 times 10 times 2 equals to negative 5 times 6. Okay, so k equals to, this is 60 minus 30 equals to 32. Okay, so that's the final kinetic energy. The kinetic energy at the bottom. Any question here? So you can see here, again, for the to apply the total mechanical energy, the equation still looks quite similar to the mechanical energy. But for the mechanical energy, you have Ku, K naught, U naught. But now you usually have one more term, the work. Okay, so you should be able to figure out the work from the definition.